Alright, so here we have the circuit for this lab, setting the input to 1, then we cycle through with the clock using the 3 main states. Inputting 0 sends us back to the 0 state. Then we enter the unused state with this switch, which turns on the flashing main light. Covering from that turns on this light here. So now we're going to switch over to the PLC clock, which requires a debound circuit that I'll cover in a bit. Taking the input to 1 here, cycles through the states again. And now let's take a look at the program driving this. So we will see here the PLC program, both reading the output and providing an input to the circuit using this debound circuit here. This circuit consists of a 100 microfarad capacitor and a 50 ohm resistor, as well as a Schmitt trigger inverter. This circuit allows us to have a clean clock edge, even though the PLCs use mechanical relays, which are rather noisy when they're opening and closing.
Alright, so at the base state of 0, 0, nothing happens when the clock ticks. Then once our input is enabled, it goes to 0, 1, 1, 0, and then it stays at that. Whenever the input is disabled, it goes back to 0, 0, no matter what stage it's in. And now if we force it into the unused state using this switch, it goes into 1, 1, and then while the input is not enabled, it self-corrects back to 0, 0. And when the input is enabled, it will self-correct back to 1, 0.
And here's our document for Lab 6. So going down here, here's our title page. Step 1, we defined the problem. Step 2, we created a state diagram with the 3 initial states here. Step 3, we encoded variables which were already encoded for us. Step 4, we did not need to minimize the machine. Step 5, we created a state table here. Step 6, we appended flip-flop inputs for the JKs. Step 7, we found simplified functions using K-maps. For step 8, we drew logic circuits. Here's the rail logic circuit and the logisim circuit. Step 9, we converted. We did not need to convert to NANDs. Step 10, we analyzed any unused state, which was S3. For step 11, we revised the state diagram to include S3. Step 12, we checked assumptions. We assumed 2 input gates only for the lab, and additionally, we assumed preset pins were active high, but were instead active low. Step 13 includes our chip circuit diagram right here.